Hi, I'm Brian from Abstract. I'm going to do a video update today so I can cover more details. So first off, I hope everyone's doing well. We're doing well here. I've been here working myself pretty much straight through these last 6, 7, 8 weeks, trying to hold the fort down, and I think we've been doing a pretty good job of it. So as of the last update, we had some PCB assemblies, the enclosure, and other things that were a little bit delayed from the original schedule. I'll get into those in a little bit. But first, right up front, I'll get into the time-sensitive items that may affect the timeline. I kind of feel like the timeline's starting to slip a little bit, but I'll keep you as informed as I can. And as soon as I have any details on any slippage that's confirmed in the timeline, I'll let you know. So the first item I want to go over is something I mentioned in one of the last few updates, is the microcontroller module. The module had 16 weeks lead time because of everything that's going on as of 4 weeks ago, around when the order was placed. So that brings us right up until the middle of July. So the actual microcontroller module brains of the device may not be here until July. So that's not good. It's not the end of the world because we've got them here. We've got pre-production parts here that we can work with and do all of the software, hardware testing, and everything else. But in order to ship the product, we're going to need to get those here. The second item is the enclosure. The sample enclosure that we ordered 2 pieces to sample before pulling the trigger on the full production. They're not here yet. They're in China. The communication is great. Everything's great. It's just from the whole COVID-19 deal that they are delayed. So the reason I'm a little bit concerned about that is they should be here in the next week or so, but when I pull the trigger on production, it's about 35 days to make them and about another 28 to 30 days for them to be shipped by sea freight to Long Beach here down the street. So that right there brings us right into July. So the enclosure is not needed until the last step, but it's obviously needed before we can ship the product or send the DIY kits. The enclosure is included in the kits. So that's the second item. The third item is the power supply cover. So we sourced a new, or designed in a new power supply right around the time of funding. You may have noticed in the BOM that the voice motherboard parts list was kind of morphing and changing a little bit. This was because the power supply was changed to a nicer, higher density medical grade device, and the post regulation for the power supply used to be with the power supply module on the side of the enclosure. Now it's integrated straight into the voice motherboard, and the power supply module screws into the side of the enclosure. So the actual cover for the power supply module was ordered 3 or 4 weeks ago. It is delayed now. I assume because of what's been going on. It's showing 11 weeks. So that's another thing we need to keep our eye on. So the power supply cover, the enclosure, and the CPU assembly. Aside from that, I'd like to be more ahead on the software. There's still a lot of work to do on the display interface, the OLED display, the DAC handling, and housekeeping everywhere else pretty much. So that's something we've got to keep our eye on. So the project will start to shift significantly towards software as we go here fairly shortly as we get towards the ship date. So regarding the PCBs, back to the PCBs, I'm going to step over here and show you them in a minute. They have all arrived as of now, and it really seems to me like they're getting back up to speed. I say this because not only did we get all the VS-1 stuff, but the Avalon stuff, our other product, we have had assemblies outstanding for more than 10 weeks. They're a bit more complicated. There's a lot of through-hole placements and stuff like that. Just they're somewhat more complicated, and they've been there for a long time. And those are even starting to ship. So even got a shipment of those. So that's good news. The PCB houses are in China. I don't know if you guys know anything about manufacturing. Some of you probably do, some of you probably don't. The vast majority of PCB assemblies come from China. whether it's Wuhan in central, or Shenzhen down in the south, or Taiwan. Time is a big PCB assembly house in Taiwan. But our PCB house was right in Wuhan. It's one of the biggest PCB houses there. And when the whole virus got started, and they were delayed that 5-week period, ended up being 6 weeks in our case before we got the parts. They communicated very well, but they were in a tough position. They went from 100% capacity down to 20 to 30% capacity, and that 20 or 30% was strictly working on electronics for medical devices for hospitals in Wuhan. This is what they conveyed to us when I would talk to them. So they dropped straight down, let most people go home and quarantine them, and only had a certain amount of people making medical devices. And then as we were communicating and waiting for some of our items and getting shipping updates, they started making those masks. Like everyone seems to be making the masks or the filters, and they were making them. So the PCB house was making them for Honeywell and a few other companies, and they were asking us and all their other customers if we wanted to buy them. So that's crazy. So they had a 20 or 30% workforce doing medical devices and masks for a good 4 to 5 weeks, 6 weeks time. And as of now, I'm told they're up to about 80%, and they're basically doing strictly PCBs. So as long as everything goes well, I think they'll be pretty much up to 100% speed shortly, and hopefully it won't be an issue from here on out. So with that, I'll step over and go over the boards, and we'll go from there. All of the outstanding boards have been received and have been built up here by hand. We have the voice motherboard. This is the new part. This is the previous version, the third version, the most recent before this one. We had to make it deeper to leave room for the new chorus board, and also we increased the spacing between the boards by approximately 2 millimeters to give more airflow. Okay, so it houses the voice cards. It interconnects to the main board and the DAC board to send all the control signals to the voice cards, and also to some of these VCAs here. You may have noticed the last couple of updates in the BOM for the DIY build. The voice motherboard and power supply BOMs have been changing. This is because some of the post regulation used to reside on a separate board along with the power supply, but we updated the power supply to a medical grade, nice, compact, high quality supply that mounts to the side of the case now, and the post regulation is now done on the voice motherboard, whereas on the previous version it was not. These are the part VCAs. This is where the outputs from the cards are summed and then sent to the output jacks. So that's the reason for the jumbling and the sort of updates in that. In fact, this has changed a little bit again. We're going to go straight to production with it, though. We don't need to vet any of the changes. You can see all of the jacks. We've got the 8 individual outputs now. We've got the audio inputs. And we've got some of the pedal and CV and gate I/O. Whereas the previous version had less I/O. It had CV and gate I/O, pedal I/O, audio inputs, and audio outputs. The 4 main audio outputs don't reside on this board anymore. We'll show that a little bit later. They're on the chorus board. And incidentally, one other change is we were able to delete the voice card guide bracket and the guide rails. The connection is so robust that these cards are impossible to move between these Molex connectors and the interlocking standoffs. So we get better airflow. We've got that bigger spacing in here. And save time and money by not having to use these. This is still the previous enclosure. The differences between this one here are the depth again. It's I want to say it's about an inch deeper, which is fairly significant. We have decided to slot the side panels. We decided that a long time ago before we even did funding, but just so you know. So the convection, the air kind of gets pulled in from here, through the voice card, so forth. And then the fan takes the air out the back. And then there's the mirror image side panel here and here. And there'll be some slots here that are used for airflow and also to mount and allow adjustment for the mounting of the power supply. So next, what I'm going to do is I'm going to show you the voice cards. So for those of you with DIY, these are the DIY cards. This is the last testing on those. So we received the cards from the manufacturer like this, and with the surface mount parts installed. There's only 3. So basically all you have on the back is an analog switch and a couple resistors on the back there. And that switch is simply to select the filter mode. However, we also made some updates to make it easier for the DIY folks versus the retail version voice cards, which are already made in-house. And we wanted to vet the changes just to make sure there's nothing funny going on, even though the changes are, you know, minimal at best. So what we did was we moved the audio output connector from a position high up on the card, which is a legacy of the OBX and the OBX voice cards. The OBX has them up here above the voltage regulators for the plus and minus 15 volt rails for each voice card. So we moved that connector right down to the bottom, so you will not need to use little shielded cables like we do on our retail units. So the entire voice card connects there. We also staggered the trim pots. So if I'm above trying to get a straight top view, the trim pots are lined up on top of each other. Now it's still pretty easy for us here with the proper tools and stuff to adjust the cards, especially with the increased spacing. But you can see here on the DIY version, they're actually staggered. So you can get down to those bottom trimmers a little bit easier. A third change we made was we allow for the use of 1.5 amp TO220 package regulators versus the TO92. Now it's not necessary, but I know how it is with DIY and whatnot. You like to kind of overdo it, and adding a few cents to the BOM is not something that you're going to frown at. So you have the option to use larger regulators on the voice cards. So I think that's about it. So these are done. These are ones we built up in-house. This is a sample from the board house. I mean, it's not much to it. So these will be coming in fairly soon and will certainly not be an issue as far as time is concerned. This is the infamous chorus board. Infamous to me, at least. So the chorus was a stretch goal in the project, and we had tested the chorus on this other unit. You know, we patched it into the unit and controlled it with this little CV test panel. So the chorus was not integrated into the system per se, as far as the digital control and whatnot. And it was just hanging wires connected, and then this little control voltage thing here to control the parameters of the chorus. And that's how it was tested before, and that's how we knew that we could add it as a stretch goal. This is the final implementation in through-hole. So it sits back here at the back, like so, and attaches to the rear panel via some standoffs and also by the jacks themselves. And those are the 4 main audio outputs on there. So you've got the chorus on here. You've got the final part and chorus level VCAs on here. You have the headphone amp on here as well, down in the corner. And that's that. Now this is the second chorus board prototype. This particular one has not been tested yet. We just finished building it, but there's minor changes versus the first one. And we don't expect any problems, but there's quite a bit of componentry on there. So to transition from simply patching the chorus in externally and controlling it externally to actually integrating it into the VS-1 required a lot of work. Of course, the chorus board itself, but in addition to that, the control of the chorus. So the DAC board had to go through a redesign. So the DAC board utilizes a single 8-channel 16-bit DAC and sample and holds, just like vintage polysynths and also the majority of modern polysynths. So what I found was all of the CV outputs, I believe it's 112 CV outputs that the VS-1 was using. All of the outputs were being used, so we had to update it and add some more parts to add those LFO rate CVs and the chorus depth or chorus amount CVs going to the chorus board. So we ended up doing some fair bit of changes. This is the previous version. We do not have the new version yet, hence why we have not demoed the new chorus yet. The chorus required some additional changes to the mainboard. Now the mainboard was already going through some updates anyway before production. But you can see here the DAC board simply plugs into the mainboard. Makes it easy for assembly and for testing, and also for DIY folks. You don't have to deal with this at all. So the glide VCAs that you can see here, these are the analog glide VCAs. There's a digital glide version as well on the VS-1, but for the analog glide, that circuitry actually resides on the DAC board now. Incidentally, you can see here the main board. This is the microcontroller module with the microcontroller, the SD-RAM, and some of the I/O interfacing. You can see the filter and VCO common CV sums, the oscillator PWM sum, common sum. Now the two global analog LFOs, the routings are all analog. So you have LFO modulation VCAs to set the depth of the modulation amount. You have LFO to PWM analog switches to route it to each destination. Got LFO to VCO. Got LFO to filter. And you've got the LFO wave selection itself, all analog. You've got noise level here. Here's the two global analog LFOs themselves. And you've got the noise source, the analog noise source, stuck way over here in the corner. Before I end this update, I'll mention that we have another video update that will be up soon, where we go over in great technical detail the VS-1 versus the original OBX and the modern DSI OB6. We go over the hardware and software designs and implementations in great detail. So for those of you interested in such things, look out for that soon. That'll be up soon. We'll also tell you what this crazy thing is here, in case you're wondering. And we'll see you then.